So we've learned how to fit a straight line to data. We've learned how to fit an exponential growth curve when the curve gets steeper. What about if the curve gets flatter? In that case, we should probably try and fit the power curve. So the equation of the power curve you can see right here is y equals a times x to the b. X is our independent variable, y our dependent variable. We don't know a and b, but the trend curve can figure it out. And again, whenever the curve gets flatter, we should try and fit the power curve. Usually does a really nice job. And the nice property of the power curve is whenever you double x, y changes by the same percentage. Okay, so let's do a famous example of the power curve, the learning curve. Now, the learning curve or experience curve, what do you think that means? Well, the more you make of something, the lower the unit cost or the lower the hours it takes to make the product. Now, it's hard to find data on the internet on learning curve, so I have some old data on fax machines. Most of us don't even remember what a fax machine is. But we have in the years 1982 through 1989, how many fax machines were made in the US and what the unit cost was. And you can see it's dropping. So if we look at cumulative production as X, the number of total units we've made, put that on the X axis and put the unit cost on the Y axis, we should be able to get a power curve. It should look like it's getting flatter. Okay. And then we can get what's called the percentage of the learning curve, which means if it's like an 84% learning curve, as we'll see, whenever we double the units made, the cost drops by 16%, 1 minus 84%. So first, let's get the cumulative production. For the first year, it's what we made so far. For the second year, it's what we made through the last year plus the current year. So we drag that down. We now have cumulative production. And our last year of data, we made 1,744,000 up to that point. Now we graph this data, and you'll see it gets flatter and it's dropping. But the power curve still works if we're getting flatter and increasing. What will happen is if the curve is flatter and decreasing, B will be less than 0. If the curve is flatter and increasing, B will be between 0 and 1. And if B is greater than 1, the curve gets steeper, but that usually doesn't fit that as well as exponential. So now if I select these two columns and I do again scatter, not line chart, there's a scatter chart, you can see that data is getting flatter. Okay. So now let's try and find the equation of this curve from the trend curve. We pick the power curve. You see that looks like it's getting flatter. Okay. Now if I select those points and I go right click, add trend line, power curve, even though the Microsoft icon says it's getting steeper, that's misleading. It's for when the curve gets flatter. So I can say display equation on chart, and we'll make that a little bit bigger. You can see it's doing a pretty good job of fitting the points. And the nice thing about the power curve, it seems to extrapolate well, unlike the exponential, to new data. Learning curves do a really good job. My experience teaching people at the Navy indicates that once you have the learning curve for, let's say, the first few planes that have been made of a model of a plane, it'll work pretty well to predict the cost of making subsequent planes, unlike exponential growth, which does not extrapolate well. So I made this bigger. Okay, so you can see we have a negative exponent there. Okay, minus 0.253. So we'll make a forecast to compare it to the actual points here. 65,259 times the cumulative production raised to the minus 0.253 power. Now, the way you raise to a power is you use the caret key over the 6. So we do 65,259 times cumulative production, caret key over the 6 to the minus 0.253. Drag that down, and there's our forecasts. And they compare pretty well to the actual. Now, what about that learning curve percentage, or the property that whenever you double X, Y changes by the same percentage? Well, let's take some examples of X. So let's suppose we go from 100,000 to 200,000, which is double 100,000, to 400,000. And I guess we could go to 800,000. So every time we're doubling cumulative production. And I'll show you the predicted cost drops the same percentage. Just copy the prediction down. Okay. Now let's see what's the percentage drop. We go from 200,000. What's the predicted cost compared to 100,000? It's 84%. Copy it down and you still get that 83.9%. That's your 84% learning curve. Whenever you double what you make, costs drop, cost will be 84% of what it was, which means it dropped by 16%. And the government and the Department of Defense, when they're negotiating contracts with companies that sell tanks and sell planes and sell ships, they understand that the 100th plane or the 100th ship will not cost the same amount as the 50th plane or ship, because people are learning how to make it better. In the final video in this course, we'll talk about the moving average aspect of the trend curve.